Okay, we're going to work through some more discriminant problems. The next being, show that the line y equals 2x minus 21 is a tangent to the parabola y equals x squared minus 10x plus 15. So the first thing that we need to do is to set y equal to y. So that will be x squared minus 10x plus 15 is equal to 2x minus 21. Then bring everything across, make equal to 0. So that will be x squared minus 10x minus 2x will be minus 12x. And plus 15 minus 21 comes across, becomes plus 21. So that will be plus 36 is equal to 0. So there's two methods here for us to prove tangency. We could do it with the discriminant. A would be equal to 1, b is minus 12, c is 36. b squared minus 4ac minus 12 squared minus 4 times 1 times 36. And that would give me 144 minus 144 is equal to 0. D equals 0, therefore tangency exists. Alternatively, I could show it through equal roots. So two numbers that multiply to give 36 add together give minus 12 is minus 6 and minus 6. So that would be x minus 6 all squared is equal to 0. So x equals 0, equal roots, therefore tangency exists. Advantage of using this method for this particular equation is that it also asks for the point of contact, and by doing equal roots I already find a bit of the point of contact, which is that x is equal to 6. I can then sub x equals 6 into y. It doesn't matter which one I choose, so I'll go for 2x minus 21 and that will give me the y coordinate. So that will be y equals 2 lots of 6 minus 1, and that's 11. And the point of contact then is 6, 11. Next question. Is the line y equals 4x minus 1 a tangent to the curve y equals 3x squared minus 11x plus 5? So again, let's set y equal to y. 3x squared minus 11x plus 5 is equal to 4x minus 1. Let's bring everything across and make it equal to 0. So that'll be 3x squared minus 15x, that's minus 11x minus 4x, and then plus 5, bring that across. That'll be plus 1 is plus 6 is equal to 0. A is equal to 3, b is equal to minus 15, c is equal to 6. So for tangency to exist, b squared minus 4ac. So if a tangent then the discriminant b squared minus 4ac is equal to 0. So let's investigate if that's true. So minus 15 squared minus 4 times 3 times 6. So minus 15 squared is 225. 4 3s are 12. 12 times 6 is 72. So d will be equal to 153. D does not equal 0, therefore tangency does not exist. Okay, next question. Show that the curve with equation f of x equals x cubed plus x squared plus 5x minus 4 has no stationary points. So for stationary points, then we know to differentiate and make equal to 0, but this must be linked to the discriminant. So that'll be 3x squared, so bring the power down, take 1 away from the power, plus 2x plus 5. So a constant x becomes just the constant when you differentiate, and the constant itself disappears when you differentiate. So if I get no answers out of this, then that would suggest that I don't have any stationary points, and the discriminant will give me the answer to that. So a is equal to 3, b is equal to 2, c is equal to 5, b squared minus 4ac. So if I get a result that's less than 0, that would suggest that there are no stationary points. So 2 squared minus 4 times 3 times 5, that's 4 minus 60. So d is equal to minus 56. Therefore, no stationary points, since minus 56 is less than 0. Okay, next question. We're going to show that the curve y equals 1/4 x to the 4 plus 2x squared minus 16x plus 5 has a stationary point when x equals 2. So the first move for stationary points is to differentiate, but again this must be linked to the discriminant. So that will give me x cubed plus 4x minus 16. And then I'm looking to investigate and prove that there's a stationary point x equals 2. So that's some synthetic division. So I've got 1 for my coefficient for x cubed, I've got a 0 coefficient for x squared, 4 is my coefficient in front of x, and then I've got minus 16. So drop the 1 down, multiply by 2, that will be 2. 2 plus 0 is 2, multiply by 2 is 4. 4 plus 4 is 8, and multiply that by 2 is 16. 16 minus 16, so I get the remainder of 0. So r equals 0, therefore x equals 2 is a stationary point. And says show that there are no more stationary points. Well, I can do that by showing that there's no more results to come out of the quotient here. So a stationary point at 2. So the quotient here is x squared plus 2x plus 8. So again, I can investigate using the discriminant. A is equal to 1, b is equal to 2, c is equal to 8. And I should find that I get a discriminant which is less than 0, which will prove that there are no more stationary points. So b squared minus 4ac, that's 2 squared minus 4 times 1 times 8, that's 4 minus 32. So d is equal to minus 28. So minus 28 is less than 0, therefore no further stationary points. Okay, final question. Show that the line y equals 2x minus 2 and the curve y equals 2x cubed plus 5x squared plus 12x plus 5 intersect at the point minus 2 minus 8. So I'll make y equal to y 2x cubed plus 5x squared plus 12x plus 5 is equal to 2x minus 2. Then bring those terms across and make it equal to 0. So 2x cubed plus 5x squared. So I've got a plus 12x minus 2x will be plus 10x. And I've got a plus 5 plus 2, and that'll be plus 7 is equal to 0. Okay, so we're looking to prove that there's a point of contact at minus 2, minus 8. So I can use synthetic division. So I should find that minus 2 gives me a 0 remainder and will factorise. So the coefficients are 2, 5, 10 and 7. So drop 2 down multiplied by minus 2 will be minus 4. 5 minus 4 is 1. Times by minus 2 is minus 2. 10 minus 2 is 8. Correction with this question, I'm looking to in fact prove that there's a point of contact at minus 1, minus 4. So into the synthetic division, and minus 1 should give me a 0 remainder and should factorise. So coefficients being 2, 5, 10 and 7. So drop the 2 down. 2 times minus 1 is minus 2. 5 minus 2 is 3. Times that by minus 1, that's minus 3. Times minus 3 is 7. Multiply that by minus 1 is minus 7. So that gives me a remainder of 0. So r equals 0. Therefore, the point of contact at x equals minus 1. I'm now looking to find the y coordinate, so sub equal y x equals minus 1 into one of the equations for y, and I'm going to choose y equals 2x minus 2. So that's y equals 2 lots of minus 1 minus 2, which is equal to minus 4. So the point of contact is, as was required, minus 1 minus 4.